In this video I'm going to talk about a range of ways that sound functions in this game using MetaSound in the Unreal Engine. I'm going to start with audio metering and monitoring. So there are metering and analyzers, audio analyzers in MetaSound, and over to the right you see the loudness meters, the oscilloscopes, goniometers and spectral analyzers. And if I hit play on my MetaSound, I could preview some of the sounds in my MetaSound source, and you can see them working, and you could do some analysis on that. But I have a lot of inputs into this MetaSound, and I would be unable to sort of find all the inputs and turn them on and really hear them authentically how they would sound in the game. So, and if you take MetaSound and drag it across and then try to start the game, those meters do not show up. As far as I can tell, you can't have them running while playing the game. So you see, yes, you can see the meters do not activate while playing the game. That was sort of the gap that I saw with metering, that you needed this kind of real-time overall look at your music within Unreal. The first one is to use a widget that is called Audio Metering Editor Utility Widget. It's available on this website. You copy the code and there is a demonstration on how to do that from this channel, which I highly recommend. So this is how that functions. I have the widget here. I press Run Editor Utility. The metering runs over here, and then when I press play on my game, the game runs with the auto metering running. So from here I can see that my levels are where they around about sit. So I can see the top part, which is the EQ sort of settings and how loud they are. Bass is quite loud here. So that is somewhat useful in understanding the overall mix. But another method I wanted to show was to actually route the audio of my game into a DAW. So if I shrink this and open up Logic Pro, I actually have the game running through that. So if I hit record the track and hit record here, the game should start playing and send the audio into Logic. You can also start to see the waveform. If I leave that there, make a few sounds, you can see the waveform as I am making sounds throughout the game. I can sort of see if any sounds are too loud in comparison to other sounds. I can see the overall balance, whether I want to master that, compress it or whatever. And that had been really useful. I just went around to my entire map and played every sound and was able to make some adjustments. You can also do some metering as well. So you just on the master channel, I'll put my U-lean meter. We can see now on the LUFS meter just how loud certain sounds get. If we were to play the game for a couple of minutes or so, we would start to get the average integrated LUFS. It should be very useful. You can also look at a multimeter. So just go down to metering, multimeter. So Unreal Engine does have a goniometer in MetaSound, but I found it I wasn't able to look at the monitoring in MetaSound as I was playing the game. So I found this method to be very useful. So that, as you can see, the multimedia was very useful there for the goniometer for left stereo spreads, working out. I do have mono. I do utilize mono in MetaSound, so I've only got mono set up in MetaSound, but there is attenuation which makes the mono stereo and moves across the stereo field, so it is a complex stereo field even though I'm using mono. And as you can see, I determined that the mono is being spread out across the stereo field fairly well. The correlation meter is generally going pretty well in +1, 0 region, and yeah, that's very useful. The ulearn meter was very useful. I can work out the average of all of it. I think one of the most useful things is to basically record lots of gameplay audio and then look at the waveform as if you're kind of mastering it, like you're visibly looking at it and mastering it, even doing it in Logic and making some changes in Logic, but then you go back into MetaSound and do some mastering. So if I now start to record some of the music in my game, so I'll basically just go through to what I would consider the loudest parts in the game, starting with the grain delay. I'll just turn the reverb on. So if I press the tab button, it takes me to my menu. A bit of it's cut off there, but if I zoom out, you can see it. I do have a volume setting on here. I only allowed the player to make one adjustment up because I've already mastered it to a level where it's loud, pretty loud, and I don't want there to be any clipping. So just a little bit of a nudge up from the centered position, but you have a lot of scope to turn it down. And I can also control that on the keyboard with letters B and H. So if I resume, I'll just exit out and adjust my screen. And I'll start to adjust the volume levels now. should be able to get it to a point where there is no sound. You can turn it down so far that it turns the sound off, which I like that function. And I'll stop it there. I'll go to Logic and stop my recording. And then I shall have a look at what the waveform looks like. I think this was the latest recording that we did. As you can see, I'm pretty happy with that recording. I think that's a pretty well mastered or mixed track. You could turn it up, but I don't think I really want to. It definitely would save it from clipping or any chances that it could somehow get louder and the combination of sounds could create clipping. So I like the look of that. It's quite well done. Some rooms turn up. There is, like I said before, there was a way to turn it up. So it's quite at a good dynamic volume. But I don't think you kind of get that analysis when you're just playing through Unreal Engine. You can't really see the overall track. You can't see the overall mastered version of your music. So it's quite easy to get lost in all the different processes, all the wave players, the mixers, the mixers and the final mastered routing section. So I think coming back to a DAW is what a lot of people are familiar with. So you can go through the regular processes that you would with anything, with any sort of music. Just allows you, just sort of grounds you a bit in reality of what it actually is and what it sounds like and how it was sound on different computers, different speakers, different environments. So these are the kinds of metering tools which I've found to be very useful. I'll just discuss how I routed it into Logic actually. I started by going to my audio settings on a Mac obviously, and I have this thing called BlackHole. So I do recommend getting something like BlackHole. I used to have Soundflower, but I use BlackHole now. So if I go to on this website, so you can route audio between apps, some free software. And so basically the output of my entire computer goes to the BlackHole routing. And then that's where my game audio will come from, the output of the computer. And then if I go to my settings, my input into Logic is the BlackHole. So it's the output of the computer going into the input of Logic. You can see it, it's just presented in a way that's more familiar to us and it's more precise. You really start to appreciate the layouts of a DAW when you're working in kind of non-linear platforms like MetaSound. And I kind of like the idea of staying within MetaSound. I liked working in the non-linear fashion as well, even though I said that. I find it's very liberating to just kind of get lost in the node process and generating all these sounds and manipulating them and not having a sort of a linear progression in the sound. It's sort of sounds kind of spontaneously come in and out and they're mixed together in a non-linear way, and that was very good creatively. But I find the final process needs to be a little bit more rigorous, firstly to eliminate clipping and getting the relative loudness levels to be at a level that is useful. So if I go to my MetaSound, I could make changes on an individual basis in the wave player, but I also have a master mix, and through this process I was able to determine that I needed a limiter just to knock off -1 dB, just to be safe, because if I turn certain things up I would have issues and there would be some clipping. I did end up deciding to use a compressor. I thought my waveform was very dynamic, which is a good thing. I want the music to be dynamic, but felt like the quiet parts were just a bit too quiet and I wanted to turn the louder parts down a bit. So I just knocked it off a tiny bit in a very soft compression, and that just helped me to narrow the waveform a little bit more, not too much, but just a bit. But you could also do things like stereo invert on individual waveforms or wave players, or adjust the gain. So I did end up adjusting the gain. I added 4 dB to my music after looking at it and determining that it could be louder. I have a few different methods in which I used attenuation spatialization. I do have a master MetaSound source, which does contain quite a lot of various types of sounds, and they are all positioned within the same attenuation, such as the sounds that you see down here, the bells and the low tones. But with sounds like the ones you find in the videos, they have been individually attenuated and spatialized. So you can see this bubble here, this sort of sphere of the attenuation that I've used. You've got the inner radius, sort of the middle one there, which would be the full sound at its full volume, and then the outer fall off distance, so the outer ring, which would be where the sound would slowly decrease in volume. Attenuation is distance. It's about how the sound fades out as you walk away from it. And spatialization is where the sound is localized, and as you turn your head left and right, it will spatialize that sound left and right of the speaker. I think the videos are actually in stereo. Some of the other sounds are in mono, and it will spatialize that mono sound throughout the space. So that's one there. That's one video there. I think there's a couple of other videos, such as over here we have another attenuation sphere. The reason why the other videos are not attenuated is because they run through MetaSound, and they have a bit more sophisticated processors, such as slowing things down, speeding things up, changing the pitch. You can do that with video, but it had a bit of latency and I needed it to be more immediate, so I used separate sound source from the visuals that you see and manipulated the audio separately. Now I'll go into my blueprint and show you how I did that. So I used spawn sound attached, and on the spawn sound attached you can put in your MetaSound source and also attenuation settings. So I've chosen my attenuation settings here, and that's now applied to this master MetaSound source. Another method I used was to use spawn sound at location, which also allows you to add spatialization settings. So so I set the location data there, and that's localized there. I think sound source attached can be attached to a mesh or some sort of object or actor, which could be moving or it could not be moving, but it's attached to something. A way that I conceptualize attenuation and spatialization, they're sort of defined as like independent elements that are controlled separately. So think about these two kind of spheres that are next to each other, but they're independent. So we also have this other graph here with like these colored lines, and this is using mathematics, so they move independently. And so that's sort of similar how the attenuation and spatialization works. They are lumped into the same object or actor, but they are separate parameters for controlling that. So some of my attenuation settings are in the browser here, and I have my volume, attenuation, spatialization, and by default the reverb setting is on, assuming that you have a reverb send already set up. If I go back to my video, I can also see that attenuation. You just go to media sound and come down, and I have enabled override attenuation. And what I wanted to point out here was something particularly about the spatialization and the stereo spread. So I particularly found that useful to change. By default it's a sort of a bit narrow, and I like to just to bring the stereo field out more for that particular object. So, and to visualize that, you can go to the settings and type in audio 3D visualize. Turn that on, press play. I can now see some of the active sounds in my game. If I come over to this video, I can see where the stereo spread currently sits. You can see these two plus signs, a red plus and a green plus. It's at a pretty good level. It's just about where I want it. And if I just exit out of this, I might make it just a bit narrow, just so you can see it a bit better. Yeah, it sort of sits a bit more narrow. That's sort of where the default was. So that stereo spread just to me gives it a bit more of a natural kind of sound. And if you go to, I'll just press stop and go to the settings, the project settings, come down to audio and go to audio quality. You can come down to panning and change linear to equal power. It just also gives a bit more of an authentic spatialization. So it allows there to be a bit of a bleed between the channels. So you hear a bit of the left channel in the right channel as it's panning, and creates, there's always a sound going on. There's never a lull period like in the center. It keeps most of the channels full most of the time and keeps the sound going. So I like those two settings, stereo spread, and that final one, equal power, in the audio quality settings. So to have a look at some of the other settings that are used. So we have attenuation, we have spatialization, occlusion, which just means that it will filter the sound if there is an obstruction in front of the sound. It's very useful. My game's a bit more abstract than that, but it's still useful to just sort of play with the sounds and play with occlusion and stuff like that to create it's a bit surreal, so a bit more surreal environment, but still a useful kind of tool to use. And again, reverb is on in that one too. So yeah, let's have a listen to some of these sounds, these attenuated sounds.